We do, that's right. For the next 40 minutes or so, we're going to be handing over to SpringOne legend, my personal hero, and the only person I know who has access to an actual DeLorean. So, of course, that is Dormain Drewitz. She's Director of Product Marketing here at VMware. So, Dormain, if you're there, take it away.
Thanks, Brian and Ben. One thing technology and humanity have in common is that they're never standing still. As technology advances, the choices we have in developing applications evolve. The promise of modernization is as much for existing applications as it is for new, so-called greenfield applications. It's funny the way history changes course sometimes. Whether it's a meteor out of the sky, a bacteria in the fleas on rats, or an invisible virus, sometimes something comes along and changes the economics of the way things get done. Containers are a little bit like that. We've known about service-oriented patterns for decades. We've always wanted to modernize applications to be lighter weight. But containers and Kubernetes came along and changed the economics of modernization and how we actually build and run microservices. Of course, the real challenge is finding the willingness to change what we're already doing. It's humbling and it's hard and it's uncomfortable. Whether you do that work or not, the world keeps turning. Your competitors keep shipping. Nothing stands still. So now that that technology has evolved, the juggernaut of Kubernetes has made landfall, leaving a wake up and down the stack. What are the challenges facing developers in the enterprise? This is by no means an exhaustive list, but here are 4 things that stand out. First, faster startups to enable new workload styles like functions as well as responsive autoscaling of applications to handle load spikes. Second, distinction and support for long and short-running applications, which have unique implications for restarts, the so-called one-factor app, and monitoring. Third, being able to scale to 0 to allow for better resource utilization and energy savings, as well as financial savings as you pay only when used. Finally, lowering the memory footprint for running multiple microservices instances. This is one of those trade-offs we face when we break up a single monolith into many microservices. These are some of the challenges raised by modern architectures, but do they only help so-called modern architectures and applications? We're constantly redefining what modern means anyways. Are microservices the holy grail of modern architecture? When you look at these challenges, microservices that do one thing and one thing well certainly stand to benefit. What about existing applications packaged as native executables so that they can start instantly? That seems like modernization in action too. As we heard from Jürgen, Spring is always embracing this evolving technology landscape while looking ahead to new applications, but not losing sight of existing applications. Joining me today are 4 members of the Spring team to take us through the evolving set of capabilities for Spring developers to use in building new, modern apps and modernizing existing applications. First, we've got packaging your applications as containers, compiling new and existing applications as native executables, optimizing the cost of the cloud hosting of your microservices, using new programming models such as reactive versus imperative or functions versus web apps, pluggable activation and invocation models that allow the same set of functional workloads to be exposed as different application styles, such as a REST call or messaging or more. By doing so, you're effectively deferring the nature of the application to the assembly and packaging. But first, let's talk about 1543, because that's why you're all here, right? Okay, indulge me for just a moment, I promise. This is relevant to our first Spring Spotlight. In 1543, Henry VIII of England got married for a 6th time. The Ottomans captured key cities in Hungary, and a Polish mathematician published an argument that debunked the long-standing model that the Earth was the center of the universe. Copernicus's theory of heliocentricity literally changed the presumed center of the universe. These charts may look similar at a glance, but there's an important difference. Look closely at what's at the center. It's a lot like what we're seeing in the Spring Boot world today. And to tell us more about the changing center of the universe in Spring terms, I'm pleased to introduce Madhura Bhave, software engineer for Spring Boot.
Thanks, Dormain. Hi, everyone. I'm excited to talk to you about the new center of the universe. And since this is a spring conference, I'm going to be focusing on the center of the JVM universe. When it comes to the JVM universe, what I really mean by a new center is that there's a new unit of deployment. So let's take a look at what that means for you as a Spring Boot application developer. And for that, let's take a step back and look at how Spring Boot applications are typically run. Once you've written your source code, one of the easiest ways to run a Spring Boot application is using the Maven or Gradle plugin to create a fat jar. A fat jar is a self-contained jar which contains all of the application's code and its dependencies, and it can be run using java-jar, or it can be deployed to a cloud platform. Now, as we all know, the only constant is change. And one of the more recent changes in the software industry is the rising popularity of Kubernetes. What does that mean for Java applications? Well, the first thing you need when deploying an application to Kubernetes is a container image. That means that the unit of deployment to deploy an application to Kubernetes is not the fat jar, but a container image which packages up the application and all of its software dependencies. At this point, you're probably wondering, well, how do I get from a fat jar to a container image? And like most software developers, you go to Google. You type in how to create a container from a jar, and the first few results might not be exactly what you're looking for. So you scroll down a bit more and get to Dockerfiles. It's always been possible to package a Spring Boot application as a Docker image using Dockerfile. So you copy-paste that Docker file, run Docker build, and get a Docker image. If we look closely at that Docker image, it consists of 3 layers. The base layer has the OS, on top of which is the JDK layer, and then the last layer has the application's fat jar. But this is not optimal. There's a few reasons for this. The entire contents of the fat jar are in a single layer. This means that whenever the application's code changes, the entire layer, which includes your application's dependencies, needs to be rebuilt, which results in a waste of time and disk space. The second reason is that the application is run as a fat jar, and when running the application as a fat jar, there's a certain amount of overhead associated with it. So one way to optimize the Docker image for a Spring Boot application is to split the fat jar into multiple layers. As you see here, there's one layer for dependencies, which tend to change least frequently. There's another layer for the Spring Boot loader classes, a layer for the snapshot dependencies, and the topmost layer is for the application's code. So whenever the application code changes, it's just that topmost layer that gets rebuilt again. To help you create these optimized layered images, we've added image creation as a first-class concern in Spring Boot 2.3. The Docker file that you see here is an example Docker file from the Spring Boot 2.3 reference documentation. It might look a bit verbose at first, but it's more performant. It is a multi-stage Docker file where the first stage is used to set some things up that the second stage will then use. To help with image layering, we've added something called a jar mode, and the first one that we're offering is Layer Tools. When the jar is launched using the Layer Tools jar mode and the extract option, the jar can self-extract itself into layer folders. These layer folders can then be used in the second stage to create a layered image. The way that Layer Tools knows which layer folders to extract the jar into is using a layers index file. We've provided sensible defaults for the layers index file that should work for most Spring Boot applications. If your application has special requirements, you can customize the layers index file using both Maven and Gradle. The next thing I want to talk about is the buildpacks.io project, or Cloud Native Buildpack. Docker files are just one way of creating container images, but they require you to know a lot about how Docker files work, which application developers shouldn't necessarily need to learn about. The buildpacks.io project is an open source project developed jointly by VMware and Heroku, and it can take your source code and turn it into a container image without using Dockerfiles. Not having to learn about Dockerfiles and how they work is just one advantage of using build packs. There are several other advantages, an important one being automated security patches. I guess you're wondering if this is another tool that you need to learn about. And the answer is not really. We've got your back. With Spring Boot 2.3, there's direct integration with the cloud-native build packs via both the Maven and Gradle plugins. You can use the Maven or Gradle plugin to create a container image for your application using build packs and a single command. The build packs have been updated to honor the layers index file, which means that any customization that you've applied to the layers index will be available in the resulting image as well. Your Kubernetes journey doesn't end at image creation. There's a few things that you need to set in place to ensure that the application runs smoothly in production on Kubernetes. To determine if the pod is alive and ready to accept traffic, Kubernetes uses something called health checks or probes. In Spring Boot 2.3, we've added Kubernetes probes as a first-class concern and exposed them via Spring Boot actuators. You can use the actuator liveness and actuator readiness health groups to signal to Kubernetes if your application is alive or if it needs to be restarted, and if it's ready to accept traffic. Graceful shutdown is another important feature when deploying to a cloud platform such as Kubernetes. Looking into the future at Spring Boot 2.4, we're planning to add support for Kubernetes volume-mounted config maps and secrets, and make those available as property sources in the Spring environment. We've deployed our own production application, start.spring.io, to Kubernetes using the new Spring Boot 2.3 features. We hope that these features, along with the upcoming ones in Spring Boot 2.4, will enhance your experience when running a Spring Boot application on Kubernetes. If you want to learn more about how Spring Boot and Kubernetes work well together, I'd recommend watching the breakout session by Stefan and Brian. Thank you very much, and back to you, Dormain.
Thanks, Madhura. So you saw how Spring Boot is making it easier to package up your Spring application into a container. That's useful. Containers, of course, are lovely because you don't need a full operating system in the image, making them lighter weight. So what if we took that approach up to the JVM layer itself? To tell us a little bit more about where Spring is going with respect to so-called native executables, please welcome Spring Framework committer Sébastien Deleuze.
Hey, I'm Sébastien Deleuze. I work at VMware as a Spring Framework committer, and today I would like to talk about the path towards Spring Boot native applications. GraalVM is a project started several years ago by Oracle. It allows, among other things, to perform ahead-of-time compilation of a Java or Kotlin application in order to generate a native executable that can run on its own without the need for a Java virtual machine. Such native executable can then be used to create a lightweight container image. There are two main benefits in doing that: instant startup with peak performance available immediately and lower memory consumption. Project Laden, recently announced by Oracle, will introduce this kind of native ahead-of-time compilation to the Java platform and to the JDK. While those new capabilities are super exciting, I think we need to keep in mind that they offer different trade-offs compared to the JVM. While native executables really shine on startup time and runtime memory footprint, they offer lower throughput and higher latency because they use a more basic garbage collector and can't optimize that path during runtime as the JVM can. Compilation takes much longer and consumes more resources. The platform is also less mature, but it evolves and improves very quickly. So let's talk about the current status of Spring support for native applications. Spring and GraalVM teams have been collaborating very intensively to make it possible to run Spring Boot native applications. Here is a quote from Thomas Verslinger, the GraalVM founder and project lead, who said, "We are excited about the great partnership between the Spring and GraalVM engineering teams to support native ahead-of-time compilations for millions of Spring Boot applications. This is a game changer, enabling low memory footprints and instant startup for these workloads. As a result, most of the GraalVM bug fixes and improvements required to run Spring Boot native applications have already been done. It is currently possible to compile Spring Boot application to native executable thanks to the incubating Spring GraalVM native project. We have just released the 0.8 milestone, and the compatibility is for now limited to a subset of Spring Boot starters. We observe between 3x and 5x reduction of the memory footprint compared to the JVM, which is very significant. It is available for you to try with your application and start to flesh out any issues early, so feel free to try it. Notice that we are also contributing GraalVM native related improvements to other open source projects we are involved, like in Tomcat. Upcoming Spring Boot 2.4 release based on Spring Framework 5.3 already integrates improvements originally incubated in Spring GraalVM native. We have also incubating support for Spring Boot native application in Paketo build packs, since they enable to build lightweight containers. On this slide, you can see that we are using a minimal Ubuntu-based image consisting of only 7 packages optimized for security and size. I'm now going to show you a quick demo of the famous Pet Clinic sample compiled to a Spring Boot native application and deployed as a container. Notice this is a regular Spring Boot application using annotation, controllers. We also have a domain object. And we are going to the Maven configuration in order to indicate that we want to create a native application. In order to do that, we are going to leverage Spring Boot support for creating container image that's available as of Spring Boot 2.3. Here we specify a dedicated builder that allows to create a native image. We also specify a few command line arguments that will be forwarded to the native image compiler. For the purpose of this demo, we are going to add a dependency on Spring GraalVM native, because here we are using the latest development version. Spring GraalVM native is this project where we incubate the support for native application. You can go here on the issues to raise an issue if you find something. You can also follow the roadmap. And we also publish a reference documentation if you want to learn more about that. But back here, we have specified our configuration. So now we are going to build the native image via the command maven Spring Boot build image. It will run our unit tests, and if everything is okay, it will start a container, run the native image compiler that will translate, with the help of Spring GraalVM native, the JVM bytecode of your Spring Boot application into a native executable. It can take a little bit of time, so we are going to fast forward here. Okay, we now have a lightweight container with our native application in it. We are going to our Docker Compose configuration. We already have a MySQL service, and we are going to add a Pet Clinic 1. Okay, so we now are going to start the MySQL service. And we are going to start our Pet Clinic service, which is in fact a lightweight container with a native application. Notice that it starts very fast, almost instantly. And if we go in the browser, you can see our regular Pet Clinic application that works perfectly fine. You will learn more about how to deploy this kind of application as a scale to zero application with Grant demo. So let's now talk about the next steps. The Spring team is on a journey to optimize the cost of running any Spring Boot application by supporting native ahead-of-time compilation in order to achieve scale to zero capabilities and reduce memory consumption. Combined with Kubernetes-based platform like Knative, that means you can run your regular web application in a serverless fashion and only pay when your application is used. There has been a hidden gem in Spring Framework 6 5.0. Functional bean registration, which allows to register beans using lambdas. With this mechanism and some related changes we are working on, it is possible to achieve out-of-the-box Spring Boot native application support with a 5x memory footprint reduction without changing the Spring Boot programming model that you all love and use. Spring Boot 3, based on Spring Framework 6, is expected to provide first-class support for native applications. to give you more options when it comes to deploying your Spring Boot application as containers on Kubernetes. We intend to adapt Spring to GraalVM native as well as project native. The related changes will optimize the footprint of Spring Boot application on the JVM as well. I think what is unique about our effort is that we not only target new Spring Boot applications, but also the millions of existing ones. Thanks.
Thank you, Sébastien. Exciting stuff, right? There is definitely room for faster start times and lower memory consumption in existing applications. But in some cases, it's almost required for some newer architectural patterns. It all comes down to changing the economics to unlock these innovative new patterns. Functions and serverless are some great examples of where those fast startup times are really useful. Scale to zero becomes a practical option. Here to tell us more about how Spring is enabling Java developers to write functions so much more efficiently is Spring engineer Oleg Zhurakousky. But first, he's going to talk about one of my favorite topics, besides medieval European history, ice cream.
Thank you, Dormain. So we just heard about scale to zero capabilities and how they support new serverless apps from Sébastien. So let's look at one of those approaches you can take to implement these apps using Java functions and Spring Cloud Function Framework. But before I get all tech and functional on you, let's talk about something important, something that will really help us better understand the value of functions. And that is, of course, ice cream. Why is ice cream so important? Well, I, for one, have never met a person who doesn't like some kind of ice cream. It is something that easily connects people, and it is something that happened to be a very relevant to Spring overarching message, a message that hasn't really changed since the first release of Spring in June 2003. And that is, user concentrates on functional requirements, and Spring helps with non-functional and boilerplate concerns. Well, how so? What is the relevance? Here's the story of two strawberry ice creams. Well, actually, it's the same ice cream captured in two stages of serving, and it helps illustrate the core Spring message in a kind of a tasty way. The picture on the left shows a scoop of ice cream simply thrown on a plate, and the picture on the right shows the same scoop nicely decorated, plated, and served to trigger additional senses, or to add flavors, or to simply charge you more. Whatever the reason may be, the contents of the ice cream never change. What has changed is how it was decorated, plated, and served. So now we have a simple implementation of Java function that does something. In this case, it simply uppercases the string, but it knows nothing about how it is going to be decorated, plated, and served to ensure proper invocation within the given context. Functions are like the scoop of ice cream. They're raw material. They represent functional aspects of your requirements, such as add user, access account balance, uppercase the string, but have no knowledge or awareness of anything non-functional. But now you can decorate and serve its functionality, let's say, over HTTP, effectively turning these functions into a REST endpoint. Or maybe you want to turn it into an RSocket consumer or producer, which supports many RSocket operations. There's actually going to be a whole breakout session on functions in RSocket. Or maybe you want to deploy to one of the popular serverless platforms, such as AWS, Azure, Google. Or maybe you're considering a full-blown messaging app where the same function acts as a message handler with its input and output corresponding to different broker destinations, which in itself opens up a very interesting opportunity where you can now start thinking about creating these distributed pipelines and data flows. Whatever the nature of the application may be, the function is still uppercase, the ice cream is still strawberry, and the only thing we're changing is the non-functional world around it. And we can accomplish it with the magic of Spring Cloud Function and Spring Boot. All right, so we're at the point of a mandatory bullet point slide. So, what is Spring Cloud Function? It is one of the frameworks from Spring Cloud portfolio, which promotes implementation of functional requirements via Java functions. It provides a uniform programming model that, amongst many things, supports transparent type conversion, function composition, POJA functions, reactive support, deployment support, and many more. It also provides adapters in the form of Spring Boot auto configurations for a variety of serverless platforms, such as Microsoft Azure, Amazon AWS, Google Cloud, and so on. So let's see it in action.
So here we have a simple function, which is uppercase. And the first thing we want to do is we want to expose this function as a REST endpoint. So within this project, we're going to go to its POM file. And as you can see, I've already exposed these two dependencies, which is Spring Boot Starter Web and Spring Cloud Function Web. So all we need to do now is start the application. We're going to go to the browser. We're going to type uppercase, which is the name of the function, and hello world. And now we got yourself a hello world uppercase. So just like this, a simple function became a REST endpoint. But please note that from the application definition, this is just a plain Spring Boot application. All this decoration came from by declaring certain auto configurations within your compile. Moving on, now we want to do is we want to turn this function into a message handler. So in this case, we're going to be using RabbitMQ and Spring Cloud Stream Rabbit Binder, which provides capability to treat this function as a message handler. Again, just expose a dependency, start the application, and then we're going to go back to the browser. We're going to go to the Rabbit console, and we can see in exchanges we have uppercase in binding. So we're going to click on it and type hello world, and we can see at the console the function was executed and the message was uppercased, and everything worked as expected. Moving on, now we want to turn this function into an RSocket handler. So all we need to do is, again, expose the dependencies, require dependencies. I'm going to write a little RSocket client code here just to make sure we can invoke it. And we can simply run the app. And as you can see, the function was invoked and everything was uppercased now via RSocket. And last but not least, we can now also deploy this function, for example, into one of the serverless platforms. I'm going to use AWS for a demonstration, AWS Lambda. So again, this is, I'm actually showing one of the samples that we have in Spring Cloud Function. So function sample AWS. Here we have the configuration. As you can see, it's identical function, which is uppercase, and just a simple Spring Boot app. And for the sake of saving time, I've already deployed it. So I'm going to go to AWS dashboard. Here is the uppercase function. I'm going to click on it. And we're going to invoke it with the sample output input. And here we go. We got yourself an execution.
As you can see, the concept of handling non-functional requirements is delegated to opinionated Spring Boot auto configurations, typically requiring very limited to no involvement from the end user. These auto configurations not only satisfy the dependencies required by the application itself, but they also decorate the function with execution context-specific behavior. So, the result, functions are simple, expressive, extensible, and portable. Most, if not all, requirements could be expressed with functions. In fact, I'm going to challenge you. Think of requirement past, present, or future that you cannot express with functions. See if you can think of one. Testing. Testing a function's application becomes very simple since you only need to test function itself. Delegate the rest of the framework that you're using. The list of these benefits goes on, but no matter how long it is, the results are still the same. Any functionality expressed as Java functions can now be exposed as a variety of applications by simply providing the relevant auto configurations. And that's it. So, enjoy your functions, enjoy your ice cream, and back to you, Dormain.
Thank you, Oleg. Who's ready to write some functions? Did anyone else feel like there was a seriously Oprah moment when he let all those different apps activate the same function? Like, you've got a function, you've got a function. Just think, you can have your own Oprah moment writing Spring Cloud functions. Look under your chair because you've got a function under there that's just waiting to be activated. Okay, enough jokey joke time. In all seriousness, no function or application for that matter is an island. The apps, functional or otherwise, connected to messaging brokers in a way that was just demonstrated by Oleg, can effectively communicate with another app where the data produced by one app may become an input to another app, and so on, effectively creating a data-driven pipeline. as we think about all the novel ways of using data that Ajay referred to this morning, AI and machine learning and IoT use cases, and how to actually build those data-driven pieces of functionality into our applications, we're going to need to support those event-driven architectures. The good news is Spring totally lets you do this. The challenge is, how do we orchestrate lots of these messaging-driven functions and other services, some of which need to share streams of data? Here to tell us more about that is Spring software engineer Elia Gopinathan.
Thanks, Dormain, and hi, everyone. Streaming and batch applications play a crucial role in modernizing data-driven applications. In the previous keynote, my friend Oleg mentioned how one can bind a simple function's input and output to a messaging system using Spring Cloud Stream framework. In a way, that simple function would look like this: simple and straightforward to deploy and manage, a single car on an open road with no turns. But in reality, it's not just a single application or a single function you would end up deploying and managing. Typically, this involves multiple applications forming a streaming pipeline and all the operational concerns around them. In other words, your production deployment looks more like this complex interchange during rush hour. This is where Spring Cloud Dataflow comes into play. Spring Cloud Dataflow gives us a tool to first construct a streaming pipeline of individual applications or compose batch applications. Second, it lets you automate the deployment configuration. For instance, if you're deploying your streaming application into Kubernetes, Spring Cloud Dataflow takes care of generating Kubernetes manifest files based on your stream configuration. Spring Cloud Dataflow also gives us continuous delivery option for individual applications of a stream or batch application. Finally, Spring Cloud Dataflow lets you securely manage streaming pipelines and batch applications on top of metrics and monitoring support from Micrometer library. With this, let's see a demo. I have set up Spring Cloud Dataflow on Kubernetes. I got RabbitMQ installed as my messaging system. I have also configured Wavefront to monitor my streaming and batch applications. I have also pre-registered the container images of the out-of-the-box applications, which were pre-built using the RabbitMQ binders. And Spring Cloud Dataflow provides a web user interface. And for this demo, we are going to use just that. And for this demo, I'm going to create streaming pipelines that ingest HTTP events. And this is how my HTTP event looks like. A HTTP post request with the user ID set as one of the headers, and then the payload with the purchase transaction information. With this, let's create streaming pipelines. We are at the streams creation page. Here, you can drag and drop the individual applications, connect them to form a streaming pipeline. The pipeline here represents the underlying messaging platform, meaning both HTTP and JDBC applications are distributed applications connected via a RabbitMQ exchange, with HTTP source acts as a producer to the exchange. JDBC sync acts as a consumer to the same exchange. For this demo, I have 3 streaming pipelines. With my first stream, ingests all the incoming purchase records into a database. The second stream gets only the credit card purchases into a MongoDB data store. My third stream extracts the zone information from the credit card purchase records, transforms that zone information, and logs it. As you can see here, we can tap into an application's output and create multiple streaming pipelines. This is because of the consumer group support that Spring Cloud Stream has. Every time a new stream is created from an outbound endpoint, a new consumer group is created, making the stream a unique consumer to its producer's output. At the time of stream creation, you can add the individual application properties in the context of the stream. In this case, we've got an application property for the HTTP source to map the request header. For JDBC sync, we got the column mapping and then the table name. For MongoDB, we set the collection name. And for the filter, we got a spell expression to allow only the credit transaction. And similarly, for the transform, we got a spell expression to just extract the zone information. As you can notice here, we have not specified any of the connection parameters of the database which we can specify at the time of stream deployment. With this, our streams are ready to be created. I've got MySQL and MongoDB databases created on Kubernetes with their corresponding table and collection. With this, my streams are ready to be deployed into Kubernetes. Let's get to the stream deployment page. Here, one can choose a specific Kubernetes account to target the stream deployment. Also, you can provide deployment properties that are specific to Kubernetes objects such as pod, container, deployment, and service. In this case, for the HTTP source, I want to set a load balancer type for its service. Similarly, for the JDBC sync, I want to associate the MySQL database's config map to its pod. With this set of properties, my stream is ready to be deployed. In the same way, we can go ahead and deploy the rest of the streams. Here, I want to add the MongoDB config map to the sync and deploy. You can see the corresponding Kubernetes objects getting created as this stream gets deployed. You can also see the previous stream's objects here, and you would also see the load balancer for the HTTP source. With this, let's deploy our third stream with the default settings. We've got all the streams deployed successfully. Let's post some events to see them working. Now, after posting these events, I expect all the records to be available in my MySQL database and only the credit purchase records available in my MongoDB, and the zone information of the credit purchase record is expected to be in the logger streams log output. Let's see that to confirm the result. Yes, now we can confirm the stream's working. Let's say I want to update the individual applications of the stream. This could be change in the deployment properties. Say I want to add a new resource limit, or I wanted to add a pod annotation. Or this could be a change in the application itself. Say you have a business logic change or a bug fix. So you would register a new container image version and select that here. Or this could be a change in the application property. For this case, I'm going to change the filter logic to allow both credit as well as debit purchase records. When I update the stream, only the applications that have changed are going to be updated. Now you can see that the stream is updated and versioned. We can roll back to a specific version of the stream as well. Now we can post some events to confirm the stream update. And let's make sure that the MongoDB has both credit as well as debit transactions, and MySQL has got all the transactions. Since we have configured Wavefront to monitor our streaming applications, we can go to the Spring Cloud Dataflow dashboard in Wavefront and monitor our streaming applications from there. Similarly, you can compose, schedule, and launch batch applications using Spring Cloud Dataflow. We have a dedicated breakout session on Spring Cloud Dataflow. My friend Glenn and I are going to present various features on Spring Cloud Dataflow there. So stay tuned, and thank you.
Thanks, Elia. Folks, thank you for taking this journey with me through these evolutions in Spring that are opening up new patterns and use cases, as well as ways to improve and modernize existing applications. Be sure to check out the breakout sessions to go deeper on each of these topics.